Welcome back to another UE5 MassAI Crowd video. Part 2 AnimationBlueprint. If you want to learn how to use city sample characters as MassAI agents, I suggest you watch part 1 of this MassAI Crowd series. In this video, I'll be showing you how to make an animation blueprint to get city sample characters walking around in your own project like they do in the Matrix demo. We'll start by defining some structs. Then we'll be adding some references to animations in our data asset. We will be creating and implementing a blueprint interface. And lastly, we will create an animation blueprint, add a BlendSpace, and we'll be working with animation curves, do bone blending and translation, add a bit of IK before we hit play and see our characters come to life. So let's get started. So we want to add animations to a character blueprint, but there's 6 different body types, so we need a way to define which animations play on which body type. One great way of doing that is using a struct. So let's go create a struct. There's already some structs in here. We find them on the city sample crowd, character, shared, and structs. In here we can create 2 new structs. Let's go to blueprint, structure, and let's call them crowd, animation, definition. Let's create another one. We'll go to blueprint, struct. Now we call it crowd, local, anims, definition. Let's go back into the crowd animation definition and add, no, we have the variable here. So we change the type to a crowd, logo animation. Let's call that one logo. Save. Now we open the crowd logo animation definition. This one has to be an animation sequence. Object reference. Let's call it walk. Walk forward. Just add 3 more. Call it walk forward quickly. Idle, base animation, and we can add a normal idle animation. Let's save, exit. Let's go back into the crowd animation definition. Save that one too. Now let's go into the crowd body outfit definition. This is where we have the different definitions for each body type. Let's add a new variable. Call it crowd animation. We can call this animations, and let's save and exit. Now we have to go into the gender definition. It's very important, or else we get an error. You see we already have an error here. This is not good to go. One way to fix this is simply by adding a variable, saving it, deleting it, saving it, and now we're good to go. Let's quickly come back to a character and let's go into the BP Crowd character data asset blueprint class. And in here we have to recompile, and we get our two genders back with the information we need. So let's save. And we go back to the structs we had. Now let's go back one to shared. We go into data, and here we have the crowd character data asset. This is where all the different body types and animations and textures and everything is defined for each body type. So if we open it up, we can see here we have the male, the normal weight, yes, the body, different heads, different outfits are in here, and we simply have one for each type, so that's 6 in all. But we have our animations down here that we added, and here we can simply find the animation we need. So we have a male normal weight, so we type in MTN walk. We want to find the walk F, add it, yes. We do the same again, walk. Now we want to walk quickly forward, and MTN idle. We find the normal idle one. There's 2 to choose from, but let's take the 30 frames, like that. This is an animation that drives a lot of the curves we need for the other animation. So we have to have a base animation, it has to be this one, and the actual idle animation we want to play when we're idle. We can choose whatever variation we want. Let's do E, and we've done the normal weight. Let's go to the overweight animations. Normally we would type male overweight walk, and we can choose a variation of their walk. We could add later on, we can have all and do a random one, but for now let's just keep it simple. There's a lot we have to do today. So let's do the same again. There's no walk quickly though, so we have to use the one from the normal weight character. MTO idle. Get the idle. Let's go to the females. Normal weight, animations, local. So we type F for female, FT for female, normal weight, so we add N. We want to walk forward. We want to walk quickly. We want our idle base animation, and we want a random. Save this and exit. Let's go back to the struct, and we find character, crowd character definition. This is where all these individual ones, when they choose, the random code chooses which one of the different definitions there is in here. They all get sent into this one, where there's simply only one type here. So this is the one that holds all the information on the character as it got randomly generated. And we want to add our animations in here. For crowd animation. So let's save that and exit. Now let's go to the crowd character blueprint and let's enter our character. Now let's see here, this is where he gets all the random information from, what to use. Let's add a new variable, call it definition, and change that to a crowd character definition. Good. So we go to the construction script and we see here the random. In here gets all the random information gets picked in here and it gets put into this crowd character definition. So we want to set this one in between here. And let's go back in here, because underneath our get body outfit definition data, now we have our animations here as an output, and we want it to get put into the crowd character definition. So let's add an output here, and that's a crowd animation definition, and there's only one, so we don't need a git save, we just plug. Now let's back up one bit, and here we got a hook up the animation output to the animation input here, and now we're done. So let's save. Go back. Now we have this information about which animations to play, but we want to pass it on to the character blueprint. So we can do that easily without casting every time, simply by making a blueprint interface. And I only recently found out how to use these, but I absolutely love them now. They're really easy to make and they just make your life a lot easier. So let's call this Part2 AnimationBlueprint. And in here we gotta add two functions. We want one on update. The updates are variables, and we want one on initialization that sets everything up, so we don't have to call it again. But let's say let's call this one get character update. Let's make another one called get character set up. Now let's add some outputs to our character update, and we want floats for all of them. Let's pick a float, and we need 4 in all. The first one we want is the speed he's moving by, and play rate the animation should be playing at based on the speed and some other factors. Then we need the direction, and lastly we need the stride. Let's do the setup quickly too. In here we want 2. one of them is a crowd character animation. Let's go with the logo. Want the logo? Let's call them logo anims. And the other one we want is a special one. We want it as a name, and this one we're gonna call layer database pose name. And we'll find out how to use that in a second. But that's our interface. Now if we go back into character, we can go to class settings. Under interface here, we will add our interface, and I will call it an IF character animation blueprint. Now when you add that one here, you get some functions over here, like character setup. So that's really nice. And here we want our animations that we're going to be playing based on what random body type we have. So let's drag in our character definition and let's break it up. And down here we have some animations. Let's break that one too. For now we only want the logo, and we're going to add, in the next video we're going to add some accessories. So that's why I made this the logo one. Makes it easier the next time around. So now we can, now the animation blueprint can fetch these data on setup, and we want a animation layer, animation database pose layer name, not layer, so curve name. And you'll find out what it is. We just set it up, but then we can do it later on. So we want to get the gender. The gender is not in here, but if you go under options, no, of course down here, character options, you can find a gender, and we can find our body type. Let's drag both those in, and then based on which gender we have, so we can say select based on which gender. Then we want to return a name for this layer. So each has 3 different body types. So if we select from the body type, there's 3 options, and we say the female ones here, and I'm just going to copy paste this one. I'm a little bit lazy. So the name has to be layer data underscore base pose underscore, and because it's a female normal weight, we say FTN. Let's copy paste this. And because it's an overweight, we change the N to an O. And here we change the N to an U. And let's copy paste this one. Because if we have a male, then we don't want the female normal weight, we want the male normal weight. And we want overweight. And we want the underweight. So this is the information we need when we initialize our animation. Yes. Now let's just save it so we don't lose our work. Should we go to update? There's some more work we need in here. We will need, most of it's based off our character movement, so let's get that one in here. and from there we want our speed, and we get speed by getting velocity. We get the velocity. But that's a vector, so we want to get the length of the vector, so we say length, and we only want the x and the y. We don't care about if it's falling or not. It's not the speed we want, so we get this one, and this one returns the speed, so we plug it right in there. Now we want the play rate. That is technically our speed divided by the scale of the animation. So the scale, they scale this one. So if we get the scale, and we want the relative scale in 3D, and we want to break this because we know it's going to be uniform. So we just need one the axis. This is going to be how tall they are, and the taller they are, the longer they step. So we play the animation a little bit slower to keep the same speed. So now we divide our speed by our scale. Plug that into the play rate. We can always, on the other side, on the animation blueprint, we're gonna do a map, but for now it should be good. Now we get our direction, so let's say get actor row. Okay. I want to calculate direction, and there we need the edge rotation, and we need the velocity, and now we have our direction. This stride, we need to get our speed, and we do a map range clamp, and go from 0 to 100, and that's 0 to 1. We remap it, and then we plug it in here. Now we can go to the mesh, and we don't want it to initialize too early, so instead we make sure everything is done here first, and then we say mesh set anim instance, and we do a new animation blueprint, so that's set when everything else is set up, and we're done in here. So let's close it, and now the hard part comes, but let's get to it. Now our advanced animation graph, we can sadly kill it, but we'll make a much better one. Let's start by going to AnimationGraph, and let's actually make 2 new functions, and we'll call one setup, and let's call the other one update. Let's start with the setup, we want to get a reference, so we say try to get pawn owner who's playing this animation, and we know exactly who's playing the animation, but we can say interface does implement interface, just to be sure. The interface we want is an IF. So if he does that, then we call the interface here that was get setup, and let's make a variable type local. Local animations, that's what we're going to call it. And let's set it to be the same as the one the character had. And then we want this little fella, layer, yeah, data, base, pose, name, and the type is name. So let's set that one too. That's pretty easy. We can add a new category. Let's call it setup. And move those in here. And let's actually add a bool and call it do updates. Sometimes it runs the tick before it actually initializes all this, and we definitely don't want that, so we set it here to true, and it's false to start with, so that's good. So now we allow our update function to work, and let's start by getting this one and say if we're true, we have to do the animations, do the updates, I mean. Then let's do the updates. And here we want to try and get our pawn owner. But now we know he implements the interface, so we just say get update. Character updates. If we're allowed to run, we do that. And let's create some floats for those. And we can give them a category, call them update. Let's add another variable here, and this is boolean, and it's called enter idle. And let's set the base of the stride. So if the stride is equal to 0, then we enter, and if it's not, then we can't enter. It's pretty simple. And let's do the play rate, and now we gotta git, right click, say git curve value, and the name of this curve is taken from the animation we're playing is move data underscore speed. And then we take the play rate we had earlier and we divide it by the curve value from the animation, and then we clamp that information. It's a float clamp. Clamp it between 2 is the maximum speed and 0.8 is the minimum speed we'll be playing at. So we need to get the base name, and we need another curve, and the name of the curve is whatever we stored in here. So let's do a new float. And we're gonna call it layer data base pose. Let's set that directly in there. Update it, and we get another curve, and we know all the most of the movement animation is based on the male normal weight, so he's always the base layer. So let's type in the database post, and let's make another one, call it layer, data base post male no. Done in here for now. Now we gotta add 1, 2, 3, 4, 5, 6 animation layers. It's only actually 5, I'm sorry. First one we're gonna call first layer. Second one is the base layer. Then we have a layer blending. Let's actually call it blending layer. We have an IK layer, and we have an accessory layer. And we're going to use it now, but we're going to use it too when we add accessories in the next video. So for now we're going to use it for the idle animation. We can actually, so Epic called this first layer, we can call it local local layer, because that's what it is. And save it. Let's open the local layer. And in here we want to add a state machine. So we add new state machine. And let's call it local motion. And from that we want to do an inertialization. You know, this is based on a curve. And the curve name is move data underscore rotation delta. Again, this is something that comes from the animations we're playing. So now let's open up our state machine and let's drag from the entry point and add a new state. Let's call this the idle state. Now let's double click idle, and in here we want a sequence player. And we want a modify curve. And the sequence we want to be playing is a male normal weight underscore n underscore idle. Let's go with the 30 frames idle. And we want to add a curve pin. So we type in layer, data, pose. We find the normal weight pose, male normal weight pose, and we activate it. Give a value of 1, then we go back. And from the idle state, we drag up and add a new state. This is our walking state, and we want our walking state to always reset on entry. So click that one, and we want to be able to go from walking back to idle. So do that. Now we find idle to walk, idle to walk. So it asks us if are we allowed to start walking? And if this is not true, we can enter and we can't enter, that means we can walk. So let's put that there and go back. And we say walk to idle. So can we enter idle? And we can, if this lets us. So now we have a way to do that. Now let's open our walk, and in here we want a blend space. And this blend space and the sync group name we want in synchronized animations. If we call it locomotion, and we have our axis information. We're going to use a grid, and sample smoothness is place. We want a weight of 3. To output here, and now we want our axis The horizontal axis is our direction. And we can go from a minus 180 to 180. And we want 8 different animations to play. And we want to snap into grid. And the vertical one, and we name that stride. It goes from 0 to 1 with 1 grid division. And we want it to snap to grid. Let's get our update. Direction. Get direction. And we want our stride. Get stride. Now let's double click. In here we go to 0, 0, right click and add new sample. You can name it if you want, but it doesn't really matter. Now double click the new sample. And here we want the sequence layer. So we go to this one. And we want to expose our play rate as a pin. And we drag play rate in there. And we want it to play a specific animation, so we go to the sequence, and we want it to play a male normal walk in place animation, and we want it to sync from the graph to the graph. Yep, that's all we need right now here. Now let's add another one over here. Add another sequence player. Paste that one. Do the same. We want it to sync with the graph. We want to expose the pin, and we want it to play male normal underscore n underscore walk left forward in place, like that. And we can play rate. Click it up here. Let's copy paste this one so we don't have to do all the settings every time. And let's make another one at the end here. Double click it to enter. Let's place our sequence player. Actually, let's copy paste both of these. Everything else is right, yes. And here is basically walking backwards. So we just act as if we're walking forward. Like that. Come out and go to the other side, add a sample. Paste this one, hook it up. Then we change the animation to a walk right forward in place. Like that. And add another one over here. And that's just gonna be place like that. Now let's come up here and add a blue sample. Open it up. And here we want the same, we want 2 this time. And we want to expose sequence as a pin on both of them. So we'll play the ones we have in our local animation. Let's get it. Let's break it up. And we want this one to be our walk forward, and this one to be our walk forward fast. Now let's get a blend node, just a normal blend node. I'll get up here and we want the speed to determine which one we use. And if we click it here, we can clamp it. So let's map range it, clamp the result, interpolate the result. And in, we want it from 180 to 200. We go B, fast, quick. And the out scale, there, the out is 0 and the max is 1. Is this something with scale? Interpolation, speed. Epic uses 5, so let's put it to 5 too. Down here, let's just save it. And let's add a new sample this side. And here we want to play the animation that is called walk 45 front right. That is all. The sync is good, yes. Let's make another one over here. Sync it up, and here we want the animation called walk right front. Something like that. Then we got another one here. Here we want to be playing a walk 45 back right. And the last of the rights. We find the animation called walk back, like that. Save it again and go to the other side. And we want walk 45 front left. And we want to walk left front. Here we want to walk walk 45, back left, and our last one up here is gonna be a walk back. Okay. So let's save it, compile it, close BlendSpace for now. Some of these little layers. Oh, maybe we should add an event in here. To initialize, we want to run our setup function, and on update, we want to run our update function. Now let's go to the base layer, and here we want to have a blend. And we want don't need this one right here. Want this one and that one, and we want this one, that one. And the A input is always going to be the same. That is going to be an mtn underscore n underscore idle. And we're not going to play rate it, so can remove that one. And this one is going to be, let's expose this one, and we're not going to play rate the idle animation. Now let's get our local animation, break it up a little bit. And here, remember we're in the base layer, so we got to do the idle base. That's where it gets a lot of the curves from. So it's important you pick the right one here. Let's just turn off debug. And we want it to blend depending on the layer base pose. So we get this one. And we plug it in here. Pretty straightforward. Let's compile it, save it. Let's always save it when we compile. Now, let's wait with the blending there to the end. Let's go to the RK layer. Click the RK layer, we want that input. Just give us a little bit of space, it's not too much. And then we drag from this one and we want to say local to component space. And here I would advise you to save, because when I drag the bone transformation in, the editor crashed. So just go up, save quickly, and nothing bad can happen. And then we want the transform modify bone. And this bone, let's just save everything. In here we want to bone to modify. We want it to be a virtual bone, so say VB, and then we do the phi left, and then we want to translate don't need a translation. We do need a translation mode though. And we're going to add it to existing. And we're going to do it in BlendSpace. We don't want to expose the rotation either. In the rotation mode we ignore. Do it in component space. And the scale we ignore. We don't want the pin. And we technically don't need the alpha either, so let's remove that. So all we do in here is we modify the virtual bone file. We add it to existing and we do it in BlendSpace. Now let's copy this one and change it to the right file. And now we want a 2-bone IK function. Oh, that was not that one. We want the 2-bone IK. And in here, the IK bone we want is a foot. We start with the left foot and do the non-IK. And then we want it to be able to stretch. We want it to be able to twist. We want to do the bone space. We want to take the rotation from the vector space. Yes. And the end target. That is our IK. Foot. IK foot left. And the location we don't need, so let's remove that. And then we go down to joint target, and we want to do that in BlendSpace too. And the joint target is our virtual bone. So we do the virtual thigh left. And let's remove that pin. And we simply copy paste that and change it to the left. I mean to the right. So the right foot. And the right IK. And the right thigh. Right, yes. Let's remove the alpha pins too, like that. Oh, yeah, it gets converted back to local space. Okay, I crashed here, so I think we have to give it an input before we compile it, because we can save it though, don't have to do it again. And maybe we should go to the AnimationGraph now. So let's go to AnimationGraph so we can compile this, and let's drag in the IK layers, the last one, and we need the blending layer. And I'm going to give it a try. Yes, now we can compile. Okay, well, while we're here we might as well pull in the rest. Let's get our local layer, base layer, and our accessory layer. And let's quickly go in here, click it. Here we want 3 inputs. First one is local. Next one is the base. And we got the accessory. Let's just do it like that. So we're done in the animation graph, that's all we need. Let's save it first and then compile. And base layer we got. Let's do the accessory layer. And in here we want our animations. Break it up. And here we can play our idle. First we need a sequence player. And we need to add this sequence as an input, like that. And room. And here we want to right click and we type in modify. Let's modify the curve. We need two of these modify curves. The first one, we're gonna add some curve pins, and this is all the curves there is on the skeleton. When I was prepping the example, I deleted all the any bells and all that. You can do that, or maybe I'll wait for the optimization video, show you how I did it. But anyway, when we're in here, mark one of these, start typing, say layer. Maybe you can't. Oh. Layer data. Let's copy paste this because we need it a lot. And the first one we do is the head, layer data head. And we add another curve. I can't copy paste, but if we type L, delete and quickly paste it, we can. And now we need something called the head add. Add a curve. We need the spine. We need the spine add. It's unbelievable, like that. Spine add, and we need the arm left. We need the arm left add. Same for the right arm. Right arm. Right arm add. Then we need the lower body. And we need the lower body add. Then we make sure we have give them a value of 1, so they get activated, I would call it. And let's drag it over here. So we start by activating all the curves, and then we add some curve pins over here. And over here we want the lower body. With lower we want the left arm. Want the right arm. And we want the spine. That's the last one. The spine. And we keep all these at 0. And now the alpha from this one we get from our gate. Oh, we don't have a gate. Let's add that in. Float. Call it gate. I had to look it up what it was. It's apparently it's how you walk. The style of your walking or something. Anyway, we hook this one up here. And should be good. Doesn't sync. Shouldn't sync. So let's save it first and then compile it. And we better go into our update and we set it based off a curve value. And that curve value is move data underscore gate. Like that. Like that. We set it like that. Add a pin here and we hook it up. Now it should work. Done in here. Now we only got the blend layer. Now in here, let's move this guy far away. Now the first thing we do here is drag off this out. New save sketch pose, cache pose, and let's call it local. We'll do the same for all of them. Call it hash. Dynamic. Let's right click, make dynamic additive. We're going to need 2 of those. We want this one to be mesh space additive, and we don't want the other one to be. It's going to be local space. So the base, we can right click here and we say cache. We want the base layer. Let's use the base, and we want our local to be added to it, and we want the same down here in the local space. And let's cache this one. Make a new cache, and let's call it local edit mesh space, and we do the same for this one. Call it local edit local space. Now give it more room. And let's go down here. Now we apply a mesh space additive. And we want it to be our cached base layer. It's the base. And we want our mesh space additive. So we add it to this one, like that. And now we blend it to B, and we blend it to the cached logo. And we want it to blend based off an alpha input type of curve name. And that curve name is layer data underscore lower body. Let's cast the result of this to a new save. And we call it lower body. Now let's comment it and call it lower body. Copy and paste that one. And this one we call spine. Change the lower body to spine. But here we want to change this value to a input of a curve name too. And that is simply curve name layer data spine underscore add. And we do one more of those. Do one for the head. Change the spine name to head. Change spine name to head here. Should be good. Yes. So let's call these mesh space. Now we gotta do the arms, and let's copy paste this one. But then instead of the mesh face here, delete that one. Right click, mesh. Now we need the logo space. And we want the head to be arm underscore left add. And over here we want it to be underscore left, like that. Oops, we forgot to rename these. Left arm, copy paste it, change it to the right arm, gonna blend them all together. So let's get our layered blend per bone, and see it has a blend mode of branch filter, and the branch filter to add here we need to have a bone name, and for the first blend we do spline, non-capital spline underscore 0 run, and we want it to go 5 layers deep, 5 bones deep. We want to do a mesh face rotation blend, and we don't want it to override, and we want to blend the motion blend based on root bone, and that's about it. Let's copy paste this one a bit. Let's do the first one here. Let's right click, cache, lower body, that's the base pose, and we want to cache the spine, the other pose, and we weight it to 1. And this one put in as a base pose for the next one, and here we want to change the bone name to neck. Remember, no capital letters here. And we get the cached head. Put it in here. Let's copy paste this one again. Again, we put it down here. Go in, we change the name. And this one, this time the bone name we want is a calico left, and we want it 2 deep. Oh, did we check this one here? 5 deep. This one should only be 1 deep. This one's 2 deep, and we right click, go to the cached left arm, copy paste it again, output to input, the bone name of this one is probably just going to be the right. Everything else is the same. Get our cast right arm. Now we copy paste this one, but we got to change this up a little bit. We actually don't want it to branch filter at all. Don't want mesh base. Want it to override. Want to keep the root motion like that. And we need another one of these. The same properties. And we right click, we get our cached local layer. Base, and we need a base layer, and we want to blend in pose 0, this one, and we want the output. These is the base. And now we're done, technically. And we can just hook it up here. Let's save it before we compile it, so don't lose it all if we crash. I hope you understand what we did. So, compile, it worked. Now let's just go back into the blending layer, because I found out I made a mistake. See all these base poses, they should have been the accessory pose. So if we right click here and go to find references, two first ones are good, and then we need to change all these other ones. So let's do that. We want it to be the cached accessory pose instead. So let's just make sure we don't have any more. So we say find references, and we only got 2 now. So this is perfect. Let's save it, compile it, and let's give it a try. Beautiful, beautiful. Let's see if they play the idle animation. So I'm going to try and block one of them. No, let's find one of the females. They got a better idle animation. There we go. So that works. One last thing, let's go in here to blueprints and let's rename this. I think it deserves it now. Now it's a real animation blueprint, so let's call it Crowd ABP, or maybe ABP Crowd, like that. And there you go. In the next video, part 3, we will be adding accessories and modifying the animation blueprint a little bit to get the accessories working. So if you want that, hit the subscribe button and you'll get notified when the new video is out. Remember, if you get stuck or have any questions, you're welcome to leave a comment and I'll see if I can help you out. But good luck, and until next time, goodbye.